Why you must turn off auto start-stop, the $3,000 engine trap. You are driving home from work. You pull up to a red light and press the brake pedal. Suddenly, your car shudders, the tachometer drops to 0, and the engine completely shuts off. The cabin gets eerily quiet. The air conditioning gets a little warmer. When the light turns green, you take your foot off the brake. The engine violently cranks, vibrates, and roars back to life, allowing you to accelerate. If you drive a car built in the last 10 years, you know this sequence intimately. It is the auto start-stop system. The dealership told you this brilliant piece of modern engineering saves the planet and saves you money at the gas pump. But what they absolutely did not tell you is the devastating mechanical and financial mathematics happening underneath the hood. Every single time that engine shuts off, your critical oil pressure rapidly begins to fall. You are trading pennies in fuel savings for thousands of dollars in hidden mechanical wear. If you want to understand the brutal physics of why this system is silently destroying your engine's bearings, your starter motor, and your expensive battery, and why you must press that disable button every single time you drive, keep watching. To truly understand why auto start-stop is a mechanical nightmare, we have to look past the marketing brochures and delve into the fascinating, microscopic world of tribology. Tribology is the science of friction, wear, and lubrication interacting with interacting surfaces in relative motion. Inside your engine, the most critical rotating mass is the crankshaft. The crankshaft is a heavy piece of forged steel that spins thousands of times a minute, translating the violent up and down explosions of the pistons into rotational force that eventually turns your wheels. This massive, heavy steel shaft does not spin on traditional ball bearings. Instead, it rests inside semicircular metal shells called plain bearings. If heavy steel spins against a static metal bearing at 3,000 revolutions per minute, the friction would generate so much heat that the metals would literally weld themselves together and catastrophic engine failure would occur in seconds. So, how does an engine survive? The answer is a marvel of fluid dynamics called hydrodynamic lubrication. When your engine is running, the mechanical oil pump is actively pushing thick engine oil through tiny passages in the engine block directly into the microscopic gap between the crankshaft and the metal bearing shells. Because the crankshaft is spinning so incredibly fast, it acts like a water skier. It physically drags the pressurized oil underneath itself, creating a high-pressure, unyielding liquid wedge. This wedge of oil physically lifts the heavy steel crankshaft off the metal bearing. While the engine is running, the metal of the crankshaft and the metal of the bearing are almost completely separated by a microscopic, high-pressure film of oil. This is hydrodynamic lubrication. It means there is virtually zero metal-to-metal wear happening while you are cruising down the highway. Your engine could run for 1,000,000 miles in this state without significant bearing wear. But this perfect, near-frictionless liquid dance requires one thing to exist: rotational speed. And this is exactly where the auto start-stop system becomes an engineering assassin. When you pull up to that red light and the system kills the engine, the rotational speed drops to 0. The mechanical oil pump stops pumping. The oil pressure quickly decays once the engine stops. Without rotational speed, the hydrodynamic wedge collapses. Gravity takes over. The heavy steel crankshaft physically sinks through the remaining oil film, and the metal surfaces begin to partially contact. This is a state known in engineering as boundary or mixed lubrication. The vital liquid barrier is breached. Now, the light turns green. You lift your foot off the brake. The starter motor violently engages, forcing the heavy steel crankshaft to spin from a dead stop. For those first few critical milliseconds, the oil pump has not yet built up enough pressure to recreate that perfect hydrodynamic wedge. The heavy steel crankshaft grinds against the metal bearing shell as it forces itself up to speed. Microscopic layers of metal can be torn away from the bearing surface. In a traditional car without auto start-stop, an engine will experience this highly destructive boundary lubrication event perhaps 2 or 4 times a day. Over a 10-year lifespan, that is roughly 10 to 15,000 start cycles. Engineers have historically designed engine bearings to easily survive 15,000 starts. But with auto start-stop, your engine is shutting off and dragging itself back to life at every red light, every stop sign, and every pause in heavy stop-and-go traffic. Instead of 15,000 starts, a modern engine with this system is subjected to upwards of 300,000 to 500,000 start cycles over its lifespan. You are multiplying the most destructive event in an engine's life by an astronomical factor, accelerating where over long periods. Now, to be fair to automotive engineers, they are not stupid. They knew that multiplying these starts would destroy standard bearings rapidly. To combat this, manufacturers began applying specialized polymer coatings, like polyamide alloy, to the surface of the engine bearings to reduce friction during these extreme partial contact starts. But here is the brutal reality of physics. Coatings are temporary wear items. They are a bandage, not a cure. Over tens of thousands of miles of violent, repeated dragging at every stoplight, that high-tech polymer coating eventually wears down. Once the coating is compromised, you are back to raw metal grinding on raw metal. When the bearing wears down too far, the gap becomes too large for the oil pressure to fill. You develop an internal engine knock, oil pressure drops system-wide, and your engine requires a complete $4,000 rebuild. But the mechanical wear inside the engine block is only the first half of this financial trap. The second half is the massive, hidden electrical tax you are paying to save a few drops of gasoline. Starting a heavy, high-compression internal combustion engine requires a massive surge of electrical amperage and physical torque. In a traditional car, the starter motor is a relatively simple, inexpensive electric motor designed to run for maybe 2 seconds a day. If you force that standard motor to start the car 80 times a day in city traffic, it will melt and burn out in a month. Therefore, cars equipped with auto start-stop require specialized, heavy-duty starter motors. These starters use oversized copper windings, reinforced planetary gear sets, and heavy-duty solenoids to handle the continuous abuse. When a traditional starter motor fails, it might cost you $300 to replace. When a specialized auto start-stop heavy-duty starter eventually wears out significantly faster from continuous overuse, the replacement cost frequently exceeds $800 or even $1,200. And what powers this massive, repetitive electrical demand? Your battery. A standard lead-acid car battery cannot survive being drained by a heavy starter motor 80 times a day. Its internal lead plates would warp and sulfate rapidly. To make auto start-stop possible, engineers had to equip these cars with specialized AGM, or absorbent glass mat, batteries. AGM batteries are fantastic technology. They can handle deep electrical cycling and rapid recharging. But they come with a staggering financial penalty. A standard car battery costs around $150. A high-capacity AGM battery specifically designed to handle the brutal loads of a start-stop system costs between $300 and $400. Furthermore, because these systems are so incredibly demanding, These expensive AGM batteries can fail much earlier than conventional batteries used in older vehicles. Let's do the actual mathematical calculation of this so-called fuel-saving technology. Studies show that in standard city driving, auto start-stop might save you a maximum of 4 to 8% in fuel consumption. For the average driver, that translates to saving perhaps $40 to $50 a year at the gas pump. Over 5 years, you have saved $250 in gasoline. However, in that same 5-year period, the system has likely forced you to buy a $400 AGM battery prematurely, and you are rapidly approaching a $1,000 heavy-duty starter motor replacement, not to mention the silent, irreversible wear accelerating on your engine bearings. You are spending over $1,000 in advanced electrical components to save a few $100s in fuel. The math simply does not work for the consumer. It only works for the car manufacturer. Automakers do not install this expensive technology because they want to. They install it to manipulate government emissions and fuel economy testing cycles. By shutting the engine off during the exact idle periods used in laboratory emissions tests, automakers artificially boost their corporate average fuel economy numbers, avoiding massive government fines. You, the consumer, are paying the long-term hardware costs so the manufacturer can pass a laboratory test. So what is the survival protocol? How do you protect your engine bearings, your starter, and your wallet from this engineered financial trap? The solution is frustratingly simple, but it requires discipline. Press the disable button. Almost every vehicle equipped with auto start-stop has a physical button on the dashboard or the center console, usually featuring an A with a circular arrow around it. You must make pressing this button a mandatory part of your driving sequence. You get in the car, you put on your seatbelt, you start the engine, and you press the button to turn the system off. Every single time. If you find this tedious, the aftermarket automotive industry has a solution. There are small, relatively inexpensive plug-and-play memory modules available for most modern cars. These devices plug into the wiring harness behind the button and simply remember your last choice. If you turn the system off, the module ensures it stays off the next time you start the car, permanently overriding the manufacturer's default setting. Spending $50 on an eliminator module today will save you thousands of dollars in starters, batteries, and engine rebuilds tomorrow. To summarize the engineering reality of auto start-stop, fuel saving is an environmental illusion paid for by your wallet. Hydrodynamic lubrication requires motion, and killing the engine collapses the vital protective oil film. Relying on temporary polymer bearing coatings to survive hundreds of thousands of partial contact starts is an engineering gamble you will eventually lose. You are exchanging cheap drops of gasoline for incredibly expensive heavy-duty starters and AGM batteries. Take back control of your vehicle. Press the button. Keep your engine running. This concludes our deep dive into the hidden traps of the modern internal combustion engine. But the engine is only half the story. Next time, we are moving underneath the vehicle to expose the most expensive lie in the automotive industry. We will reveal the catastrophic truth behind sealed-for-life automatic transmissions, and why believing the dealership's claim that you never need to change your transmission fluid guarantees a $6,000 transmission failure. Subscribe if you want to understand how your car really works and how to protect it from the dealership's profit-driven maintenance schedules.